Okay, for this one we got questions on number 33. It says, as the moon follows its orbit around a planet, the maximum gravitational force exerted on the moon by the planet exceeds the minimum gravitational force by 11%. And then they want you to find the ratio of the radius max over the radius min, where the radius max is the moon's maximum distance from the center of the planet, and r min is the minimum distance. So basically, alright, so we have the moon revolving around the Earth. When the moon revolves around the Earth, it follows an elliptical orbit. So there are points on it where it is closer and farther than other points. So we have our R max and R min is what we want to calculate. R max represents where the moon is the furthest distance from the Earth, and R min is when the moon would be the closest distance to the Earth. They also give us the information, so we have F max and F min. F max represents the radius max, but technically F max is not really the larger force because it's actually the lesser force because it's farther away. So instead of saying F max, we're going to call it F small because it's really the smaller force that's associated with the maximum radius, and its F min is going to be F big. So basically, it said that the big force is 11% greater, which just means 1.11 times larger than the small force. There's two ways you can calculate this. We're going to use a mathematical way, and then later we're going to use kind of like the conceptual way. The conceptual way, of course, is much faster, but we break it up into our components. So we write the force of gravity equation, the large force of gravity equation. So the force of the gravity equation of the big force is G times mass of the Earth. We'll call the mass of the Earth big M, and mass of the moon is little m over R squared is equal to 1.11 times G times the mass of the Earth times the mass of the moon over R squared, the different R's. We're trying to find the ratio of R max divided by R min, so we can rearrange the equation, and we get R max squared over R min squared is 1.11 G big M little m over big G big M little m. We can cancel out some stuff, and then we get R max over R min is the square root of 1.11, which is 1.05. That's it. The way we could have done this logically is found the relationship. When we think about these equations, big G, little m, big M, they're all constants in both equations. And the relationship between the force of gravity and radius is that they are inversely proportional of their squares, which means if you double the radius, the force of gravity decreases by a factor of 4. If it was just proportional to the inverse, which is if it was just Fg is proportional to 1 over r, you double the radius, the force of gravity is half. Because the r is being squared, you have to change that. So if you increase the force of gravity by 1.11, that means that the r must be made smaller by a factor of square root of 1.11. Or in case this is the opposite, comparing the max and min, if you decrease the force of gravity by 1.11, that means you have to increase the radius by a factor of the square root of 1.11. And you could have worked out that way, or you could have done the math. I think the math kind of came a little easier. And that's it.